All right, hello algebra kids who are watching this video. We are on day 2 of review for semester. You should have up through 17 completed. If you were not here and did not get that filled in, you are going to want to because you get to use this packet on your test, just as a reminder. We are going to start with 18 today, and we're going to go down to either 28 or 29. We haven't decided yet if we want to stop at the section or finish the page. So we'll see when we get there if we're feeling 29. If not, we'll save that for tomorrow. I will be gone tomorrow, but you're going to play this video in class that I will record for you, okay? So 18, starting with 18. 18, 19, 20. I guess just 18 and 19, those are all multiplying, but the difference between the two is that 18 is not trapped. Whoa. I don't know what we have going on here. Let's get rid of this. 18 is not trapped, but 19 is trapped. Okay, so I'm going to put an NT and a T, okay? So we have to deal with them just a little bit differently. Now, on 18, I look at just the numbers first. So just negative 16, just 27, just 15, just 8, and I reduce those. Okay, so let's try to cancel some things out. What can we reduce by? 8 on the 16 and the 8, so 16 divided by 8 would be negative 2, and then this would be just a positive 1, right? What about the 15 and the 27? 3. Okay, 27 divided by 3 is 9, and then this would be 5. Okay, so on the top, you could start canceling your X's and Y's and Z's, but I don't usually just because it's kind of a mess. So I just clean the house and just do all of the tops together. So negative 2 and 5 is going to make negative 10. I have X, Y, Z squared is what I have on the top if I combine all of them. All right, what's on the bottom? 9 and? Z and X. Yep, I'm going to go X squared and then Z. I'll put them like, it doesn't matter what order you put them in. I'm just going to put them right like that, okay? Now we have to combine. The numbers are good. Negative 10 over 9 does not reduce, but now I can cancel like the X's and X squareds. I have 1 on the top, 2 on the bottom. So I'm going to be left with, let me write my negative 10 and my 9. 1 on the top, 2 on the bottom. I'm going to have 1 left on the bottom. Y's, he only has 1 on the top. He can't go with anybody. What about Z's? 2 on the top, 1 on the bottom. So just 1 on the top. Anything else I can do?
Nope.
That's all. Okay? So just go through. The hardest part of that is going to be like keeping track of like your crossing out stuff. So make sure you use good handwriting, all that good stuff. Okay?
It's like 19 like the GCS.
19 is like the greatest common factor, simple trinomial, that type of thing where you're breaking stuff down, okay? And this is multiply, so we don't have to keep flip-flip. But if it's divide, you keep flip-flip. I don't know if I give you a divide one, but anyway, that's multiply, keep flip-flip. So I just look at each piece. X plus 3, I cannot simplify. X minus 1, can't simplify. What about this top one right here? X squared minus 2x plus 1. He is a simple trinomial, and then I break him down. So what can you multiply to get 1? I'm gonna put my little notes in here. Multiply to get 1, but when I add them, give me negative 2. Negative 1, negative 1. So x minus 1, x minus 1. Negative 1, negative 1. Okay? On the bottom, that's also a simple trinomial. So I'm multiplying to get 6, add to get 5. 2 and 3. Positive for both, right? X plus 2, x plus 3, and then I just cancel things and leave what's left over.
What's the bottom two?
X plus 2, x plus 3. There you go. X plus 2, x plus 3. So I can cancel things. X plus 3s cancel. X minus 1s cancel. You can't cancel all 3 of them. You can only cancel 1 on the top for 1 on the bottom. So I will still have an x minus 1 on the top. Does that make sense? And on the bottom, I'll have an x plus 2. And that's all I can do. Right? I've had people before that try to cancel like this x with this one. Can you do that?
No.
And have like negative 1/2? I've seen that before. No, because they're trapped, right? The x and the 1 are trapped together. Okay, good? All right, number 20 is a little bit different because we are adding. Shoot. What do we have to do when we're adding? Okay, what do we have to do when we're adding? That's different. Yeah, we have to find a common denominator. Okay, but before we do that, this is a simple trinomial. Let's break him down. Okay, so what can we multiply to get negative 4, but when I add them, give me negative 3? Multiply to get negative 4, add to get negative 3. What do you got?
Negative 4 and positive 1.
Negative 4, positive 1. Okay, so now I'm going to write my two groups down here. This guy, and we need to find a common denominator. So my denominator here is x minus 4 times x plus 1, and then this one's just x minus 4. What's your common denominator going to be?
X plus 1.
X minus 4 times x plus 1, right?
Oh, yeah, whatever.
Because it has to like include everything, right? But not more than once. If you have, like, the x minus 4 shows up here also, but we already have it. Okay, then I'm going to start with the x, I'm going to start with the 3, and then we're going to multiply by what he is missing. Okay, so this x up top here, like, what does he need in order to make the bottom the same? Nothing, right? What does the 3 need to be multiplied by? He needs an x plus 1. Okay, now we just combine the tops, right? Okay, so x is just there chilling out, but this 3 can be distributed, so 3x plus 3, and then I've got this other x plus that, right? Like, this guy is just going to come over here and just combine. So the tops, I can combine the x and the 3x, and that's like 4x plus 3 all over x minus 4x plus 1. Yeah? That's all. Okay? Good? Questions about that? Okay, now, how do we do this one right here? Solve this thing.
Put x to the other side.
I don't want to do that.
Or
How do I get this?
Divided by 6.
What?
So you minus the 2 there first.
I mean, you can minus the 2 over. It's going to be kind of ugly, though. I mean, whatever. I'm going to find a common denominator and get rid of everything, right? Yeah? So here's my equal sign, right? Okay? And this is 2 over 1, right? So I have 3x and 1. What's your common denominator going to be? 3x, right? So I've got those guys, and I'm going to use 3x and 3x and 3x, right? Like this. And I've got 10, and I've got 4, and I've got 2. And then I multiply by what they need. So looking at the 10, what does he need to be multiplied by? X. Okay, what about the 4? What does he need multiplied by? He's got an x on his bottom. He needs 3x. So he needs a 3, right? And what about the 2? What does he need multiplied by? He has nothing on his bottom, so he needs everything, right? He needs the 3 and the x. Does that make sense? Okay, now, this is my favorite part. Did you forget it? What's my favorite part? You got to cross off the bottoms and then just solve, right? So I've got 10x equals 4 times 3 is 12 plus 6x, right? 2 times 3x is 6x. Okay, then I just solve. All right, I'm going to zoom in. So subtract the 6x over, yep. 10x minus 6x is 4x equals 12. And then divide by 4. And x is 3. Okay, good? And that is all. Okay, good? All right, 22 is a little complicated because it has like this thing right here. What does the 1/3 power mean? Do you remember? That's 1/3 means the cubic root. So we're taking the cubic root of all of that stuff, right? 8x to the 3rd over 27. Okay? And then we just do each part individually. So the cubic root of 8, we start there, right? Can you take the cubic root of 8? Yeah, it's 2. Like this just says, what can you multiply by itself to get 8? And it's 2, right? So the cubic root of 8 becomes 2. All right, what about the cubic root of x cubed? What do you take times itself to get x to the 3rd power? Just x, right? Okay. What about the cubic root of 27?
3.
Is 3, right? 3 times 3 times 3 is 27. So 2x over 3. That's all. That wasn't too bad, right? Just remember the 1/3 power means the cubic root. Okay? All right, moving on down. What is the domain and range of the function graphed? So domain, range. This is a reciprocal function. It's like the boomerangy thing. So like what can x be and what can x not be? Domain is x's, range is y's. So the x's go left and right. Will this thing go left forever?
Yes.
Yeah, will he go right forever?
Yeah.
Yeah, like on this side he'll go right forever and he'll go left forever. But we have a problem in the middle because he doesn't touch right here. Like he like can't go through that and he can't go through that, right? So he's not going to touch what?
-1.
-1 right here. On the x-axis, this is the x-axis, he doesn't touch -1, right? So for domain, we say he can be anything he wants to be, just not -1. So the domain is x's are not -1. Okay? For range, the y values go up and down. He will go up forever. He will go down forever, except when he tries to go through this line right here, he can't.
Yeah.
Because this place he's going to have a problem. So the y values can't touch +1. Does that make sense? The y values can't touch +1. Okay? Good, good? All right, moving on. Now we're in probability. We're going to go through this real fast. Statistics and probability. All right, 24. It's asking if this is a survey, an experiment, or an observational study. Survey, experiment, observational study. So here's the question. A fast food restaurant gives 25 of their customers a sample of the new milkshake, and employees monitor their reactions. Circle that or underline that. They're monitoring their reactions as they taste it. We are observing their behavior. We're observing their behavior, so it's an observational study. Observational study. Now, it is only an experiment if we split them in half and give half of them the milkshake and half of them something else, right? That would be an experiment. We're running something against itself, right? That's how an experiment works. So an experiment is 2 groups. This is only one group of 25 people. I'm giving them a milkshake and I'm saying, I want to see your reaction. Now, why would I observe that rather than survey them? Like, and ask them their opinion of the milkshake.
You're looking at what face they make.
Yeah, what face they make. Because if, like, you made it and you're my friend and it tastes like garbage, I'm probably going to be, like, really nice to you and be like, that tastes great. Even though it doesn't, right? So you're going to see it on my face that I think it's, like, really bad. So I'm not going to lie to you with my face. Okay, that's why it's an observational study. Okay, 25. Here we go. In a study of 150 high school student responses, 78 out of those said that they were happy with their class schedule. Now, if I actually surveyed all 2,000 students, how many of those kids would say that they liked their class schedule? How do you do this? There's a couple different ways we could.
15 divided by 78.
The other way around. 78 divided by 150.
I would do if.
Okay, what would you like to do?
If 150 is 78, I would put 100 on that plus whatever. I would just like cross multiplying.
Okay, so you're doing it 2 different ways. Here's what Eli's doing, and then we'll do your way here in a second, okay? Here's what Eli's doing. He says, okay, 78 out of 150. If I do that, that is, whatever that is. Whew. I'm going to deafen the people watching this video. 78 out of 150 is 0.52. That means like 52%, right? 52% of them like their class schedule. And if I'm surveying all 2,000, I would multiply that by 2,000, and that would give me 1040, right? That's what Eli wants to do. He said 1,040, a little bit over half of them would like their class schedule. Okay, here's what Amit says. He says, okay, 78 out of 150 is equal to how many would that be if I do all 2,000, right? And cross multiply and divide. So you're taking 78 times 2,000. Whatever that is, 78 times 2,000. And that's 156 with 3 zeros equals, cross multiply 150x. And if we divide by 150, guess what we're going to get? 1040. So either way you want to do it, if it makes more sense to you to say, like, that's what it is as a fraction or as a percentage and multiply that, or you can do the cross multiply and divide. I don't care. Okay, good? All right, here's the deal. We need to...
So is that a survey?
What? We don't have to label that one as a survey.
I just want to...
Probably. Yeah, they asked them if they were happy with their class schedule, so that would be a survey. Yep. Okay, 26. All right, for 26 and 27, you need this thing. I'm going to draw him.
Are we you gonna give
If
us
you
that?
would like to use your laminated copy, you sure can. Otherwise, I'm going to draw them on here. Okay? So here is 0. Here is +1. Here is +2. And here is +3.
Can we use this on the test?
You can use that on the test if you have it. Yep. And -2 and -3. And then we've got beyond. Okay? All right. So if I go like section by section by section by section, this is 34 point, oh, just 34? 34%. 34% live here. 34% live here. 13.5% live here. This is 2.4%. And this is 0.1%. Okay, and same thing here on the other side. So 13.5%. I have 2.4%. And I have 0.1%. Okay, so if you have this on your laminated sheet, I will let you use that. Or just copy it down on here and then you'll be good to go. Okay, so 26, the number of tickets sold at a high school basketball game in a particular conference are normally distributed with a mean of 68.7. That means he goes there in the middle. 68.7 with a standard deviation of 13.1. 13.1, 13.1. Come back here in a minute. Okay. 13.1. Okay, so I'm going to add and subtract 13.1 each time. Ugh, and I get the numbers here. 68.7 plus 13.1 is 81.8 plus 13.1 is 94.9 plus 13.1 is 108. Then we subtract. Is 55.6 is 42.5 is 29.4. Okay. All right. What range of tickets sold represents the highest 2.5%? Okay. So let's go up here to this, and we're talking about the top 2.5%, which would be this category and this category. Does that make sense? And the cutoff mark is right here. Like anything that's above this would be 2.5%. Does that make sense? Okay, so we're talking about like +2. Anything higher than +2. You see what I'm saying? Anything higher than +2. Which one is my +2 number? Which number on that number line is my +2 number? 94.9. So what do we say for the range of tickets sold? That's the highest 22.5%. 94.9. And beyond. Anything above 94.9, right? 2.5% of people are in this category, so anything bigger than 94.9. So I'm going to say 94.9 and above. Or you could say anything higher than 94.9, right? That would be in the top or the highest 2.5% of tickets. Okay? So if one game sold 100 tickets, that would be in the top 2.5% of popular games. Okay? Anything higher than 94.9. All right. 27. Ugh, now we got a new one. I thought we were going to use the same bell curve, but we're not. Okay, we got a new bell curve. Here we go. And the average is 18.6, and the standard deviation is 3.5. Okay, here we go. Let's get a new color. 3.5. If I'm adding 3.5, I got 22.1, I've got 25.6, and I've got 29.1. Okay, and then subtract, subtract, subtract. Okay, I've got 15.1, 11.6, 8.1. Okay, there's my markings. Here's 0, +1, +2, +3, -1, -2, -3. Okay, that's how many standard deviations we are above and below. Okay. It says, do I need to wait a second? It says, what percent of people are between 11.6 and 22.1? Yep. So what percent of people like are in this range right here, from 11.6 to 15.1? This would be 13.5, right? Percentage here would be 34, and percentage here is also 34, right? So if I add all those up, 81.5%. Does that make sense? So off of your bell curve, you're just going off of those numbers, what percentage are in that range. So approximately 81.5% of people would take between 11.6 and 22.1 minutes to walk to work or to commute to work each day. Make sense? Ish? If they don't, ask me. Oh man, 28, box and whisker plot, blah, blah. Daniel, we love Daniel. Everybody say thank you, Daniel. Guess what he just did? He put them in order for us. On the test, I know for a fact, because I just looked at it, that they are already in order for you, so you don't have to waste time on the test putting them in order, okay? But Daniel's got them ready for us, so he's going to read them off, and we're going to write them down. Here we go.
29.
29 is the smallest, okay?
33.
33. 34.
44.
44.
46.
46.
2 47s.
2 47s. 47, 47, okay?
50.
50.
53.
53.
54.
54.
56.
56.
57.
57.
60.
60.
Another 60.
Another 60.
61.
61.
62.
62.
63.
63.
64.
Are you just counting now? I'm just kidding. 64, okay.
65.
He is just counting. 65.
67.
67.
70.
70.
74.
74.
75.
75.
76.
76.
78.
78.
80.
80.
83.
83.
And 90.
And 90. And that's the right number because I wrote them directly underneath the other one, so I know that we got the right number. All right, so they are in order. Do we need to read them again? Did you guys get them all down? They're all good to go? Okay. All right, number of numbers there are. 1, 2, 3, 4, 5, 6, 7, 28 numbers. I'm going to write that down. 28 numbers. I think I counted that right. 28 numbers. The 5-number summary. Do you remember what that involves? The min, the max, the median, the Q1, and the Q3. And those tell me where my box and whiskers are located. Okay? Ready? Minimum number. That's easy. I can do that. 29. Maximum number. 90. Nice. All right, now we're going to find the median next. If I have 28 numbers, I'm going to write it right here. 28 numbers, and I separate them in half. How many are in each half? 14 numbers, right? Are you going to have an exact middle number? No. But if I split them in half and I have 14 numbers in each half, the numbers 1 through 14 are here, and the 15th number through the 28th number are here, right? So my middle two numbers would be the 14th and 15th number, right? So if I count them over, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Between 60 and 61. Is that what you just said?
Yeah.
Yeah? So what is the average or halfway between 60 and 61? 60.5 is my median. Okay? So 60.5. Now, if that was an actual number in my data set, if we had an actual median that was in my data set, I would cross it off. But now I don't. I use 60 when I find my Q1, and I use 61 when I find my Q3. Does that make sense? Do you know what I'm talking about? Otherwise, I cross it off. Now I have 14 numbers here to find my Q1. Are you going to have an exact middle number if you have 14 numbers? 14 numbers. I have 7 here and 7 here, which means I have 1 through 7 and 8 through 14. So my 7th and 8th number are going to be my median, right? Or my Q1. 1, 2, 3, 4, 5, 6, 7, 8 is 47 and 40 and 50. What's halfway between 47 and 50? You can add them together and divide by 2. 48 and a half, is that what you said?
Yep.
48.5. Beautiful. Okay? What? Okay, we get it figured out. All right. Then the second half of the data, it's going to be between the 7th and 8th number there as well. So 1, 2, 3, 4, 5, 6, 7, 8. Between 70 and 74. What's halfway between 70 and 74? 72. If you don't know that already, add them up. 70 plus 74 divided by 2 is 72. And now there are our numbers. Okay, now we got to draw it. So I start with a number line. On the test, I give you the number line and you just have to mark it. Okay, so here's my number line. I'm going to start down here, and what do you want to start with? What should we start with? What? 20 through 100, sure. So let's go 20. I'm going to go, can I do that? 20 through 100. 20 through 100. Let's go 30 here. I'll just go like this. 40. Just try to make them evenly spaced. 50, 60, 70. I'm going to run out of room. 80. No, I'm not. Ha. 90. We're going to fudge it a little bit. 100. There we go. Okay, so everything's evenly spaced. Because I showed you where I have like kids that try to do stuff that's not evenly spaced. Have we talked about that before? Like where I don't like their box and whisker plots. Have I talked about their box and whisker plots before?
You take most from that.
I do. I mean, if they're really far off. Like it drives me crazy when I have like 0. And then I'll have like 90. 95. 100. Like I legit have this sometimes. And it drives me nuts. Like, look at the space. You're saying this is the same distance as like that? No. So make a ruler at the bottom so you have like at least a little bit close. And, you know, you can mark it from there to actually see how spread apart they are. So 29 is our minimum number. So I'm going to put a dot right there. Okay. 90 is my max. So right above the 90, I'm going to put a dot. Then my lines go at 48 and a half. I don't know, like right there. And 60 and a half, right there, and 72, about right there. Hey, what do you think about this?
I love graph actually pretty easy.
It's actually pretty symmetric. It's pretty even. I like it a lot. Okay, so things that I will be looking for and that you need to make sure that you have on the test is this list, because that's what I'm going to go off of, okay, to make sure that your numbers are right. So yes, I will look at your box and whisker plot, but the numbers is probably where you're going to be docked points if you don't have the correct numbers. Okay. All right. Do you want to do 29 or do you want to wait till tomorrow?
Wait till tomorrow.
Wait till tomorrow. Okay. Sure. Then we'll do all the trig at one shot. I will be gone tomorrow. So here when I stop the video, I'll show you guys how to get that pulled up. Okay. We've got like 11 problems, 12 problems for tomorrow, technically. Okay. There you go.
Very good.
All right.